Now let's write this one. Let z is sine theta plus I cosine theta in exponential form. So we know that to write z in exponential form, we have to write z as the norm of z times e to some angle alpha. That's the argument of this complex number. Okay, first, what's the norm of z? So by definition is the square root of the real part squared plus the imaginary part squared. That's sine theta squared plus cosine theta squared, and we know that's 1. The square root of 1 is just 1. Okay, so we have this one as 1. Now to write this one in exponential form, we use the Euler's formula. So we know that the sine of theta is e to I theta minus e to minus I theta over 2i, and the cosine of theta is e to I theta plus e to minus I theta over 2. Okay, let's write that. So let's just plug here. Z is sine theta plus I cosine theta, and it's still raining, and the rain it's being recorded, I think. Okay, I like the rain when it's raining. It's cool. So sine theta is e to I theta minus e to minus I theta over 2i plus I e I theta plus e to minus I theta over 2. Okay, the first thing is we get rid of this I here. So we know that 1 over I is minus I. If you have seen the videos, you know this, you know it now. So first we factor out by 1/2, and we get rid of 1 over I, and let's just do one more step. It's minus I here, e I theta minus e to minus I theta plus I e I theta plus e to minus I theta. Okay, so here 1/2, and let's express everything. So minus I e I theta plus I e to minus I theta plus I e I theta plus I to minus I theta. There is something that we cancel. Oh yes, it's this one here with this one. Okay, all we have is 1/2 2i e to minus I theta, and we cancel by 2 to get I e to minus I theta. We need to get rid of this I, because here we need to have only the modulus in front of the exponent. So that's why I can be expressed as e I pi over 2. Okay, so we write it down. So we get e I pi over 2 times e to minus I theta. Okay, and using the rules of exponents, this will give us e to I pi over 2 minus theta. That means z sine theta plus I cosine theta has the exponential form e I pi over 2 minus theta. Okay, so this is the form that we need. Here we don't write 1 because the norm is 1. I have repeated these expressions over and over, and also I have split the video in many different parts to make it easy to follow. And also I use handwriting, because handwriting is a great way to learn. Anything that you do, if you write it by your hand, you will definitely remember it. Not like watching stuff and reading over stuff. No, if you do it by hand, and if you write the way as I do, you remember everything. That's what I learned, and I think it's scientifically proven. If you write by your hand and you take notes by your hand, you always remember. And what I would say is try to write these ones in like some notes, or maybe try to do these problems over and over. So you will definitely learn a lot and will be quick in solving complex problems. Okay, because our aim is to have more videos and get into the residue theorem. because that's the one of the most important theorems that we can use in engineering, in Laplace transform, in Fourier transforms, and also when we are computing certain integrals that are not easy to compute. So we use the residual theorem to do that. So my advice is that try to write everything by hand and ask questions, and share the videos and like them if you think they are good. Please share and subscribe. Thank you very much.